which is vectorless computing, internet protocol, sensing, technology, communication, embedded devices, you name it. And to be honest, this IoT, you could use it anywhere. If you are a butcher, if you are a medical doctor, if you are mechanical engineer, whatever, you are going to see everything there in the next future. And as I said, some people even expecting plus 200 billion devices. So there will be a lot of market for such technology. Now, what we have done here in this specific work, I mean, we have several students, each one doing specific things, but this is to summarize one of the student work, which is using SDN with wireless. Most of our SDN now with wired, not much work on SDN with wireless, and this is what we call it SDN-wise. And we will try to reduce the amount of information exchange between sensor nodes, and this is one of the things, making sensor node programmable. And we need to, one of the important things about machine-to-machine IoT is the power and lifetime of the battery. If you have, say, several sensors in wherever this area, say in Al-Mahmudiyah, if the sensor batteries will last for 1 week, it means you need to have an engineer with a car. You go there, obviously the petrol here and labor is cheap, but if you go outside Iraq, in Europe, labor is so expensive, petrol is so expensive, and it will cost you a lot of money if you go to change the battery after 1 week. So people thinking that the battery should be more than 1 year, even some people they think the battery should be even more than 10 years. This will depend on so many issues. One of them is having a battery with a good long time, but this depends on the technology of batteries. It's not my job. In my job, I need to find a very nice, a beautiful, very beautiful protocol. Yes, and where I will be able to find a nice protocol, and what other techniques with the protocols I need to find. I need to see something which is called sleep mode. I need to let some of the devices sleeping. How I'm going to do this? This way will show us. As I said, this is the amount of machine to machine in 2015. Please, again, if there is something not correct, excuse me here. This is 120 zettabyte. In 2020, we'll have more than 500 zettabyte. I'm going to skip this. Just to give you an, this is not from me, this is from the internet. And if you look here, we have 44 million messages every 60 seconds in 1 minute. In 1 minute, we have 44 million messages, and we have 26 new reviews, and we have 120 new account, and so on. So you will see huge amount of data here. So we need to think of how we're going to collect all these data. And this is, by the way, this you could do and use the big data here, because in big data you are going to have a huge amount of data. Those data, some of them are wrong for a reason or another. Sometimes you go to your doctor or GP or hospital and they take your blood and put your name and everything, but then this is not your blood. This is, instead of Hamid, it is in the name of Imad or whatever. This is one thing. The other thing, some of the data you don't need it. It's rubbish data. You need to exclude it. The idea behind it, imagine you have a library and you have so many books. Which book you going to take it out because you need to bring in new books? The old book always? No, not necessarily, because sometimes it's a basic, or for those people who work in history, in something geography, they need the old books. So you need to be clever enough to get rid from the bad data, whether you don't need it or it is a wrong data. Right. Let me go just to show you what the other people have done in their work. This is how I'm talking now about only energy conservation scheme. If you look here, we have so many things here like network performance, duty cycle, energy efficiency. What we treat here is the hierarchy technique. In the flexibility of network management, we have used SDN wireless. We have used all those red things. If you look here for SDN wired, so many people have used SDN wired. If you look to the standardization of your interface, so many people using Bluetooth, which is I'm not interested in. We are interested in 802, of course, IEEE 802.15.4, and there are two types here. There is ZigBee, which is okay, but for me, I'm interested in 6-LoWPAN. So this is what we have used, 6-LoWPAN. Somebody will say, why use 6-LoWPAN? For two reasons. One, it is lower power than ZigBee. The other thing, it will enable me to serve a large number of sensors because it used the IPv6. And this is what we need. And then from 6-LoWPAN, we have used as interface, we use the SDN here, wireless, and then we try to end our research. If you look here, those are the motivation for machine-to-machine wireless sensor network. One of them is difficult to manage. As I said, we don't have such a large number of IPs. Network overloaded, IP shortage problem, and limited energy. And this is very important. This is what I'm interested in. This one will be sorted out by using 6-LoWPAN. Those are the motivation, which is large-scale self-organized sensor network and so on. As I said, I'm going to leave here because I need to have some time for the question here. If you look here, machine-to-machine plays an essential part of IoT, and IPv6 is the latest IP version, which has been, which has a large addresses, and this is what we are interested in, to use the 6-LoWPAN with our sensors, and we use SDN here, and as you know, those people who work with SDN, they know everything maybe better than me, but those people who haven't seen before the SDN, it is software-defined network. The purpose of this is to have separate the control plane from data plane, and this will minimize and hopefully manage. But I think it will increase some power on the system, so you need to be careful. The other thing, I see a lot of young people, you as well, you are young, okay? So those people who are trying to do research, I think there are three things you need to keep in your mind. First of all, you need to think of what is your aim. This is very important. You have one aim, you need to think what's your aim. And all of us have a certain aim. I believe I used to have aim when I was, say, a child, and then when I was a young person, I have another aim, different aim. I want to be graduated, and then when I am a bit younger, I have another aim. For example, I want to be a prime minister. Why not? And so on. So each one has a certain aim. So let us, before we start our project, our proposal, whether it is final year, MSc, PhD, or even proposal to do anything, I need to see what is my aim. Okay, so if you look here, I need to have efficient energy consumption, load balancing for machine to machine, and so on. What are my objectives? If I want to have an aim, I should have objectives. I need to read all the literature review. I need not to miss any IEEE survey and tutorial papers to see what the other people have done. Because if I'm going to do something which has been done last year or the year before last year or 10 years ago, this is not a research. So you need to be careful about this. Those are all what our objective. If you look here, you will see that we have developed a new protocol which is called multi-level clustering multiple sync. Multi-level clustering multiple sync. And this is using 6-LoWPAN using IPv6. And if you look here, you will see that we have used as well genetic algorithm and discrete PSO, and then we have used SDN with the WISE to improve and the management. Those are the contribution. I just want to show you what we have done. This simulation has been done in using NS3. But I could tell you, some other students, they have used MATLAB. So you could use any one of them as you like. It depends on your experience. But if you look here, all those red nodes are sensors, and then all the blue node, they call it CH, which is cluster head, and then there is something which is called sync, and the sync will go to the base station or A node B or whatever. And if you look here, we have only 2 syncs, and we have so many cluster head, and the cluster head could be changed according to the threshold of the power, because we don't want to load the cluster head here, and we need to have a longer lifetime. By the way, I forgotten just to give you an idea of what is. There are so many other protocols existing, but one of the well-known protocols called LEACH, Low Energy Efficiency Adaptive Clustering Hierarchy. This is one of the well-known machine-to-machine protocol, and there is another one which is a modified one called multi-hop LEACH. And we compared our work with those two because we have used so many things, and we need to compare it with those well-known 2 protocols. If I give you an example here of our result, you will see that this is our developed protocol. In fact, this paper has been submitted to IEEE. We had the first review. We need to, and we submit the comments, and we are waiting for the result. It might be rejected, it might be accepted. It depends on your dua. Okay, now, yes, right. Now, if you look here, you see that this is the LEACH, and you see this is the 1,000, maybe 800, 500 rounds, and the LEACH will not be working anymore. If you look here, with this one, with the M-LEACH, again, with this amount of round will stop. While if you look to the protocol we developed, it is 3,600 round. It means that our lifetime is much longer than what they have developed. This is the packet delivery ratio analysis, and you will see this is the PDR percentage. This is much better here, but if you look here, we have a longer lifetime, and this is what we need. And so on. Those are the results, and this is will show you we use 100 nodes, we use 200 nodes, and we use 300. Well, some people maybe they say you need to use 1 million nodes. Of course, I mean you could use 1 million, but it will take a longer time for simulation. Right. We have used sleep mode. Some of the sensor, we don't want them. As you know, if you have a temperature, pressure, any kind of sensor, you don't need to measure the temperature every 1 second or 1 minute. If you want to measure temperature in this room, you might have a sensor to measure every 1 hour or even 2 hours, or say maybe 5 minutes. So in this 5 minutes, why you need your sensor to be switched on? So you could make it sleep in a sleep mode, and then you will save energy. So this is the 2 ways. One is without adaptive sleep mode, and I'm sorry for those in the back, maybe they will not be able to see it, but at least I could tell you that this one is without adaptive sleep mode, and this is with a sleep mode, and you'll see that when we have a sleep mode, we'll have 6,000 round. And this is similar for the remaining energy. You will see that with the sleep, without sleep mode is 3,600, here about 6,000. This is another diagram which will show you the delay time analysis, and you will see that with the sleep mode we have much better delay time. This is when we use different kind of genetic algorithm or discrete PSO. This is another kind of network performance evaluation, and you see what we have done here. Instead of only two cluster, two sync node, we have tried to divide them to 3 levels, vertically and horizontally, and we put one sync here, one sync here, one sync here, and we try to find what is the difference when we have only 2 or 3, and this is what we have got, the performance of our network with different genetic algorithm, and show us some good result for our system. This is the final system where we have the sensor, and then we have the sync node, and we have in the cloud all our SDN, everything. This is called visor. Some of the students even call it hypervisor, which is control several VMs and distribute loading on several virtual machines. This one, a simulation, as I said, with NS3. We have another student which he has done similar thing, no similar protocol, different protocol, but he used energy as well and delay as a parameter, but he has done simulation and practical work. So he had some sensors, and then cluster head, and then sync, and then after that he transmit all the information using 6LoWPAN to cloud. He had a cloud, and you could see everything. He put a temperature sensor, pressure sensor, and you could see everything done in the cloud, and then you receive all the information. Right. What else? All this performance. So I finish in a good time. Thank you very much for listening.